Good afternoon, Jill. I did receive your solution to problem 17, and I just wanted to talk through a couple of my suggestions with regards to your solution. I noticed that in your null hypothesis you said that p is equal to 0.3, and 0.3 is actually 3/10. That's not 1/3. I think you've rounded a bit too much, so I would suggest you maybe at least carry 2 digits after the decimal point for your p-value in this, for your p proportion in this case. So I might say p is equal to 0.33. Then I also noticed that in your hoe, you did not say p equals, you just said hoe equals 0.3. It is the p population proportion that is being claimed is equal to 0.33. Your ha then is stated appropriately because they did give you a direction in this one. So your ha, I agree with, would say that p is less than 0.33. Again, add that one extra digit at least to make it a little bit more accurate in your calculation. So that change in your hypotheses is going to change step 2 a little bit, not significantly. You're going to be taking that sample proportion of 308 out of 611, and you're going to be subtracting 0.33 instead, and that's going to give you a slightly different answer. And now I've got another correction that we need to make. I noticed that you said that your p, which really should be labeled p hat, is equal to 308 out of 611. I think you might have accidentally jumped to number 18, where you did have 308 out of 611. But in number 17, you actually had 172 out of 611. And that's about equal to 0.282 rather than 0.504. So that, of course, is going to change your test statistic in step 2. So in step 2, you're going to take your 0.282, your p hat, minus the claimed proportion, which was 1/3 or 0.33, and you're going to divide not by the square root of 0.3 times 0.7 over 611, but rather 0.33 times 1 minus 0.33, which would be 1.67, over 611. So again, you rounded a little bit more than I would prefer, and therefore this is going to change our test statistic, but also we're going to find that because you used the wrong or had the wrong p hat, then your test statistic will be very different from what you calculated. So when you calculate that, Erin, you're going to find that z is equal to about negative 2.72. I may have rounded a little differently than you did, but about negative 2.72. And so that's what you should have included in your step 2. Now, with regards to your step 3, I'm not quite sure where you got a p-value of 0.5802. So you're going to have to use StatCrunch. I don't know how that's done in StatCrunch, but we want to know the probability that we'll have less than, that we'll have a z-score, less than negative 2.72. And that really should produce a p-value of 0.0033. So again, I'm not sure where you got your p-value of 0.5802. So then in conclusion, remember I said today, when p is low, we reject the hoe. With your p-value of 0.5802, p is not low, so you would not reject the hoe. But with the actual accurate p-value of 0.0033, that p of 0.0033 is less than the level of significance given in the problem, 0.01, which means P is low, and that means we will reject the null hypothesis. Okay? Because our p-value is less than the level of significance given. Your p-value of 0.5802 is clearly not less than 0.01. So given your incorrect calculations, you would not have rejected the hoe. But these are the correct calculations, and so our conclusion would be that we reject the hoe. Let me know if you have other questions.